With us now is Kirk Curtis, Vice President of Video Logic, and next to Kirk, Philip Robinson, contributing editor with Byte Magazine. Jan?
Kirk, you're going to be showing us some really interesting video things using your digital video architecture. Tell us what that is, that architecture.
Well, digital video architecture is an architecture that we developed to allow people to actually have motion video on a computer screen. And this product, which is a dva4000 adapter, is one of the pieces of hardware that came out of DVA as an architecture. And what it actually allows you to do, which I can show here, is to have full motion video on the screen along with standard VGA graphics. Here I'm in Microsoft Windows. I have two different windows coming up from a video disc player. And as with any other object in a Windows environment, I can move these around. I can actually size them, make them larger or smaller.
And they're coming up proportional to the size of the window.
Yes, exactly. And I can even make one of these go to a full screen or even drop it down to an icon so that you have a full motion digital video icon here.
And could you have in Windows another non-video application running in a window also?
Absolutely. You can run Microsoft Excel, Microsoft Word, any application that ran under Windows, or we could quite literally be doing this from DOS. It doesn't require Windows or Presentation Manager.
The video processing is basically bypassing is doing it on the board rather than through the CPU of the machine itself. So consequently, you can really run anything in the background.
Yes.
While these are going.
That's right. Part of the architecture was to remove the processing and memory requirements from the host and put it onto the adapter itself. So it doesn't matter whether you've got a 286 or a 386.
Yeah. And I see as you reduce the Windows application here to an icon, I mean, we still see the video actually in the icon down there when you minimize it.
Yeah, that's due to the interpolation, line filtering, some of the techniques that we use on video.
All right, I know you have another application you want to show us in which you really would have a practical use of this, and I want to ask you to set that up. And while you're doing that, Philip, if we can turn to you. What we're seeing here is a hardware approach to desktop video, not just a software approach. What's the significance of that?
It's very significant because any approach to desktop video, the hardware is extremely important. The hardware that we have so far, even 386s or 486s, just isn't fast enough to store or manipulate the information. Video images are huge, and without special chips, and this is a good example of a chipset, you just can't make the images small enough to get them through the bus on the machine, to put them on the screen, to manipulate them and change the image size. There's no way to do it.
You've got to do that 30 times a second to get
well, sure. A single image from full screen, full motion video would be 700K. 30 times a second, you're talking megabytes per second. Just can't do it without special chips.
Kirk, you have your next application up here.
Yes, what we've got here is an example where a financial analyst might say want to have an online session with CompuServe where you're able to pull up real-time information off of that. At the same time as you might want to recalculate a spreadsheet down here. I have the spreadsheet with a graph, and I can put numbers in here and use Excel.
It's not slowing down the video at all, is it?
No, actually the beauty of this is that now I can have real-time video, not something that's coming off of tape, and I can take news that might affect the financial information that I'm tracking, and I can drop it right into my decision-making.
Again, to be clear, we're not watching the Laserdisc now. You're watching live broadcast TV, theoretically anyhow, on the screen while you're live on CompuServe looking at stock quotes, while you're playing around with that information in your Excel spreadsheet.
Yes, and this television here could be CNN, FNN, CNBC, McNeil-Lehrer.
Now, the reason that this isn't slowing down while you're doing other things, is that because the processing itself is being done entirely on the board?
Yes, one of the design considerations when we developed the digital video architecture was to not have any of the processing or memory requirements on the host, but actually on the adapter itself.
Philip, we've seen 3 different platforms now for desktop video in this program, the Commodore Amiga, the Macintosh, and now the PS2, the IBM world. How do you sort of compare these 3 in terms of future platforms for desktop video?
Well, I think none of the 3 is there yet. The Amiga had the biggest head start when it came out. It already had some ability to work with video. It's fallen a little bit behind because it hasn't kept up with the number of colors you need and some other display characteristics, but it's still one of the best. The Mac is probably in second place because it had lots of memory. It could deal more easily with more memory than the PC could, but the
There's
PC...
more of them out there, too.
A lot more than Amigas, but many fewer than PCs. And the PC has that open architecture. It's not built for video, but if you add affordable hardware,
that board,
then you start making it a pretty good video platform. So who's going to win the competition? I don't know, but the PC is such a great market.
Kirk, is that why you designed for the PC and the PS2?
Yes, the digital video architecture is platform independent as an architecture, but we came out first on microchannel, then for PCXT-AT.
Or is this a product I can buy now?
Yes, you can buy it right now today.
At what price?
$24.95.
And what do you see as the market for this?
I think the main market is training, corporate presentations, and real-time information systems.
All right, Kirk, Philip, thank you very much.
Thanks.
That's our look at desktop video. We'll be back in just a minute with this week's Computer News.